Hello, here we go. Calculator part of the Unit 3 test. There are 7 questions total, all like what you have in front of you here. Of course, there's more than 7 on this review, but all the questions are the same type. So there'll be one problem like the first 2, where all you have to do is set up a picture, use SOHCAHTOA, and solve. So the picture will not be drawn for you, but the picture is going to help you sort of figure out if it's sine, cosine, or tangent. So that's what I mean by write your ratio. That means what are you using? Sine, cosine, tangent. Put your calculator in degrees. We're going to the nearest tenth. So we have a ladder leaning against the building. Here's the building. Here's the ladder. The ladder itself, or the bottom of the ladder, it's 40-foot ladder, sorry, and the bottom of the ladder is 32 feet from the building. You are looking from the angle the ladder makes with the ground. We can assume that's a right angle, that the building is perpendicular. So remember, we're dealing with SOHCAHTOA. This is adjacent and hypotenuse. This is cosine. So the cosine of x is equal to 32 over 40. You're doing the inverse because you're missing an angle, and so the angle is 36.9 degrees. For problem number 2, it's just more of the same, just a different setup, just so you can have just another practice problem. We have an airplane 600 feet in front of a 50-tall building. The distance that the plane is, that's going to be the ground distance. That's how they're measuring it, like the plane hasn't taken off yet. And then the building is 50 feet. What angle of elevation must the plane take off in order to avoid crashing into the building? So assume that the plane flies in a straight line, the angle of elevation remains constant until the plane flies over the building. So what they're saying is this angle here. This is opposite and adjacent, so this is tangent of x is equal to 50 over 600. And x is equal to 4.8 degrees. There'll be 3 questions, like 3, 4, and 5. The directions do not give you permission to use the entire unit circle, so you are using principal values. It will say principal values on the test itself to help you kind of remember. So what angle has a tangent? That's 1. That's pi over 4. We're trying to find the cosecant of pi over 4. Cosecant goes with sine. Of course, that's radical 2 over 2, so we want to do the reciprocal of that first quadrant, so it's positive. What angle has a cosine of radical 3 over 2? So that's pi over 6. We're going to find the sine of pi over 6, again, quadrant 1, so positive 1/2. What is the sine of 4 pi over 3? That is here. So it's negative radical 3 over 2. The reason I did that and didn't just cross off the words is because I wanted to know that it was negative. Please be careful when the problem starts with an inverse like this one, that you don't just cross it off and write down 4 pi over 3, because 4 pi over 3 is not allowed, or it is not, I should say, in the inverse of the sine. That's not an angle that you can use. So inverse sine is this side of the unit circle only, and it's negative. Well, sine is positive here, so we want the one in the 4th quadrant, and so this will be negative pi over 3. You could have negative 60 degrees there as well if you'd rather have the angle in degrees. Now we are in degrees, and we're going to the nearest tenth. There are 2 solving equation problems. It would make sense to me that there's 1 degree and 1 radian. Please read the directions. Please follow the directions. No negative angles here. And we are in degrees, and you're going to need the calculator. So that means not unit circle. This is factoring because we have tangent squared and tangent and a number that doesn't have anything, so you cannot take that out. Cannot take out a common factor. So we have 3 tangent of x. Good news is there's only one way to get 2, but you got to get that 5 in the middle. So I'm going to put the 2 out here and the 1 inside. This gives me 6 minus 1. So I want the 6 to be negative, the 1 to be positive. So we get the tangent of x equals negative 1/3, and the tangent of x equals 2. Now remember, these are not unit circle values, so that's not something you should know. So the tangent is negative second and fourth quadrant. You get 18.4 out of the calculator. That's, of course, not an answer. So we have to do 180 minus 18.4. So 180 minus 18.4. 360 minus 18.4 is 341.6. Tangent of x equals 2. This is a first quadrant answer, so you do want the angle from the calculator, 63.4 degrees. And then, of course, 180 added to that, because we're going to go into the third quadrant, 243.4 degrees. Number 7 only has one word squared, so not factoring. We'll just get this thing set equal to 4. So we'll add the 4 to the other side. 25 cosine squared theta equals 2. Divided by 25, equals 4. So we get cosine squared of theta is equal to 4 over 25. Take the square root, get a plus or minus, so you'll have 4 answers. The cosine of theta is equal to positive and negative 2/5. You'll get the first quadrant angle, and then you have to find all the answers in all 4 quadrants. So number 7 is 66.4 degrees, 113.6 degrees, 246.4 degrees, and 293.6 degrees. For 8 and 9, now we've switched to radians. Again, calculator, no negatives. Number 8 looks like a GCF. They have a sign in common. So we'll take that out. Leaves you with 5 sine theta plus 2. So the sine of theta equals 0. And then the sine of theta is equal to negative 2/5. Well, the sine of theta equals 0. This is a unit circle value. You can use the calculator. There should be 2 numbers, right? 0 and pi. You can call it 3.1 if you'd like, because it does say to the nearest tenth, or you can call it pi. Negative 2/5 sine is negative, of course, in the bottom 2 quadrants. So we get 2.7. That's the angle from the calculator, plus pi. Remember, you're using pi here, not 180. And then we have to do 2 pi minus the angle from the calculator, and we get 5.9. Radians have no units, no symbol. For number 9, it's not factoring. I'm going to add 5 cosine theta. So we have 9 plus 3 cosine theta is equal to 10, and then subtract the 9. So the cosine of theta is equal to 3, and then divide by 3. Cosine of theta is equal to 1/3. So this is a positive 1/3, so that means the first quadrant is what we want, and that's what we get out of the calculator, so that's 1.2. And then the cosine would be in the fourth quadrant, so you would do 2 pi minus 1.2, and that gives you 5.1. There's only one problem, like the ones on the back. It has a couple parts, though, each one. Well, each one of these, but the one on the test. So you're going to come up with a picture for a situation that's not really specifically sine or cosine. It's supposed to be more of a real-life situation. Then you are going to write an equation based on your graph. The idea is that the graph helps you set it up so you can see if there's a shift, if it's really sine or cosine, so that you can just get a better feel for it. So we have Tony floating in a tube in a wave pool at 1 second. He reaches the maximum height of 14 meters above the bottom of the pool, and at t equals 9 seconds, he reaches the minimum height of 2 meters above the bottom of the pool. We're going out to 17 seconds. There's 9. There's 10. There's 17. And we're going up to 14. This is time in seconds, and this is the height of Tony in meters. So let's just put some points on here. At 1 second, he's up at 14. At 9 seconds, he's 2 meters. So there's 8 between them, so 9 plus 8 is 17. So 17, he's back up to 14. So it does not touch the axis. So we definitely have a shift left and right. It certainly, to me, looks like cosine. So I'm going to go with cosine. You know you can pick cosine or sine. The sine first 0 would have to be at their first, the first point would be that 0. Or you could back it up, I guess, to the left, but it would probably be easier to visualize to the right. Half of 1 to 9, so half of 8 is 4. And that would be up to 8. Because 14 minus 2 is 12. So if we think about the amplitude, is 1/2 of 14 minus 2, so that's 12, and half of 12 is 6. So our amplitude is 6, y equals 6. I'm going with cosine. So if you think about 6, 14 minus 6 is 8. So this is your new midline. So the whole thing has been moved up 8. So whether you use sine or cosine, you're going to have a 6 and you're going to have a plus 8 at the end. And we need the period. The period is 16 seconds. So 16 is equal to 2 pi over b. So we get 16b equals 2 pi. So it looks like we're dealing with pi over 8. And this moved 1 to the right. If you do sine, it would be 4 to the right. And it'd probably be negative, yeah, because it goes down first. So if you did sine, it would be y equals negative 6 sine pi over 8 still, x minus 4 plus 8. I think I have minus 4.5 on the answers. I think I was going to 9, but it's really obviously half of 8. So that's why it's a 4, not a 4.5. Sorry about the mistake on the back there, or at the bottom. And I'm sure there's other answers than that. Those I think are just the two that are the ones you can do with the least amount of thinking or work. For number 11, Sally. Oh, Sally and her bike. She's riding her bike home from school, picks up a nail in her tire. Tire hits the ground every 2 seconds and reaches a maximum height of 48 centimeters. Assume the tire does not deflate. Oh, that's good for Sally. Oops, sorry. All right, so sketch a graph of this periodic movement. It does not tell us how many periods to draw it for. I guess I'll draw it for 3. I have to go up to 48. This one is got a lot less details because the tire gets picked up on the ground. And so every 2 seconds, right, the tire's on the ground. So that means that every odd number is up high at 48. This again is time measured in seconds. This is the height of the nail, and that's measured in centimeters. Middle of it is 12, and the amplitude is 12. I like to draw the midline because you can see kind of how far you are from, if you want to use sine in this one. Looks like you'd be about half, right? If you think about half, 0 to 1. I'm going to go with cosine. I think, again, that's easier. So y equals, this is cosine, it's upside down, negative. Amplitude, half of 48 is 24. I'm going with cosine. the whole thing got moved up 12. Oop, I don't know, what am I saying 12 for? 24, sorry. The whole thing got moved up 24. So in that case, your amplitude and your shift up is the same. And our period is definitely 2 seconds. So 2 equals 2 pi over b. So 2b equals 2 pi. And so we divide by 2. Pi is the value for b. Don't forget your x. If you want to do sine, sine is not reflected. We would have y equals, amplitude still 24, sine. Pi is still the b value. This got moved 1/2 to the right, and then of course the plus the 24 at the end. So again, your choice, or come up with another one that I didn't offer. I'm sure there's lots of other correct answers, but that's how the test will be too, where you can kind of come up with whatever you need, whichever way you see is best. Please make sure though you calculate the value for b. That's the one thing that's not on the graph. Period's on the graph. B is what you need in the equation.